Okay, so today we'll be learning about the basic Arduino coding, basic uses of sensor that we'll be using with our Arduino projects and ESP32 as well, and we'll be learning how to do sensor fusion to make different kinds of project. The prerequisites for this is that you should know how to do coding for Arduino. If you don't know, I have added a video link in the description. From that you can learn. Next, now I'll be showing you how to download Arduino IDE, how to use basic sensor, their basic codes, and how to use them together, make a project, and how to use help of AI to help you code. So even if you know basic syntax, you will be able to do Arduino coding without having to learn each and every line of the code. You just need to know the basic syntax. So let us get started. So see, this is the document that I will be sharing with you. Arduino IDE installation, everything links have been given here. So see, this is the link that we will be following. Okay, so here this is that link, Arduino IDE. Here you will click on download button. Okay, then some kind of this thing will pop up. You have to just press on download, then double click on this after it gets downloaded. As I have already downloaded, I won't be downloading it again. So this is the Arduino IDE that I will be opening. See, this is the basic thing that you will be seeing in your Arduino IDE. So after this has been done, first you have to select the type of board that you will be using. So I'm telling you, we will be using Arduino IDE with Arduino. Okay, so this is the Arduino that I will be connecting. First I will show you how it looks like. Let me switch the screen. Okay, so this is how a Arduino looks like, and you will need a cable to connect to it. So this is the cable that we will be using. You need to connect it to the USB port of your laptop. So let's just get connected. It lights up, it's working. Okay, so now let's get back to our screen with Arduino IDE. Here on this drop down, you have to just select. It directly shows it's an Arduino Uno, so just you have to select it. Just in case if it doesn't show, you have to go in this board section, manually select this Arduino and select on Arduino Uno. That's the one that you are using. And also if COM port is like that, you have to select the COM port. So if you want to check which COM port you are using, so you just have to create Windows device manager. Okay, in Windows if you search device manager, this thing will pop up. Here you just have to see ports, and you will see USB serial device COM12. Okay, so this is the port that you are using for Arduino. Okay, so there we get it. So now we are confirmed that this is Arduino Uno working on port number 12. So now with this I'll show you the sensor that will be going through. Okay, so these are the jumper cables that we'll be using to connect the different kinds of sensors. This is a female to female, male to female, and male to male connectors. And now I'll be showing you basic sensors. So see, this is a display. Okay, this is an LCD display where you can display your projects data, like let's say sensor information and stuff. This is an ultrasonic sensor. Okay, this ultrasonic sensor, you can measure the time required for a sound wave that hits a wall and comes back to it like an echo. So here is we got a transmitter and we got a receiver. It hits here, comes back, and then we calculate the time. Through that we get our distance. Then we have a motion sensor. It detects the motions around it using IRs only. This is an IR sensor. This is also kind of transmitter receiver only, but how you can use it, if you have a black color, it absorbs light. So what happens is when there's black color, the light will be get absorbed, and this will give out value as 0. These things give value as 1 and 0. So if you get 0 and you get 1 when there is no black color. So in this way you can use an IR sensor to make a line follower or any kind of thing. It can even detect distances, because you can, with the help of this potentiometer, adjust the distance at which it will detect. Okay, so then this is the buzzer, just to make some kind of sound. You can change its pitch. I will be showing it to you through the code. Then this is an potentiometer. So what it does is it has variable resistance. So if you are supplying some kind of voltage through it, so with the help of this resistance you will be varying that voltage, so you can control the speed of anything or direction. Because if let's say you got a servo motor that I will be showing, you can change its direction with the help of this potentiometer, because you will be changing the voltage and that those works on that only. Okay. So this is an OLED display. This is just a better version of that LCD display, because it's an display like you can see on your screen mobile phone these days, but it's much more better. Then this is a breadboard power supply. You'll be using this power supply sometimes and sometimes not. This can supply 5 volts and I think 3.3 volts. Okay. Then here we have our servo. So these servos work on PWM signals. To study more about PWM signals, you'll have to search on YouTube and you'll find how it works. Like PWM signals are just highs and lows, but for that you'll have to study it properly. They'll show you proper diagram and everything. So but I'll just tell you briefly how it works. If you just change the voltage, okay, then you can just change its direction. By the way, this is a metal gear servo and this is a plastic gear servo. The difference will be just in stability. This will be much more stronger compared to this one and much more accurate. So these are the basic sensors that we'll be using. One more that I'll be showing you is this 9-volt battery. To make our project independent of let's say wiring, we can just add this and attach this in the Arduino, and it's just free from your laptop now. It will work without even having to power it from the laptop. So now let's get started. Let's start with one of our first sensors that we'll be using. So the first sensor that we'll be using will be this one, ultrasonic sensor. So here it is. This is the ultrasonic sensor that we'll be using. Just as I explained before, it just transmits. It's a transmitter and receiver. A wave hits some kind of wall, it bounces back, and it calculates the amount of time for it to come back. So with the help of that, it can calculate the distance. So now I'll tell you the basic wiring that we'll have to do for it to work. We'll be using male to female jumpers. So here we go. So there is a ground pin and a VCC pin. Okay. What is a ground and what is a VCC? VCC will be the positive terminal of your ultrasonic sensor, and ground will be the negative terminal of your ultrasonic sensor. Trigger and echo pin are, as you can just say, it's just the echo that comes back. Okay. So let's get to it. We'll use orange as our trigger pin. We'll be needing one more jumper and we'll use this echo with a black pin. Now as we have connected this, let's see how we'll be connected on the Arduino board. First of all, you got to connect this thing on the 5 volts power supply provided on this Arduino board. Okay, after you have gotten this, you need to connect this ground to this ground that's been shown right here, just beside the 5 volt power pin. Now our trigger pin needs to go on pin number 10, and our echo pin needs to go on pin number 9. Our basic connection has been done. Now as we are done with our connections, we'll get to the Arduino IDE and we'll learn how to upload the code, and let's just see. Okay, so this right here is our code. from where I just got this code is here. You can see in the guidebook. You just need to copy this code, go in Arduino IDE and just paste it. Okay, so see, we have set our we need to set our pin numbers. It's 10 and 9. Then we need to set the baud rate at which the laptop and this Arduino will communicate at. Then after that, as I just said, there is a trigger and there is an echo. So what it means is there is a transmitter and there is a receiver. This is triggering the pulse and it's being received as an echo by this echo pin. Okay, so what we have said, trigger, the wave that's going out from the sensor as output, then that wave that's incoming is the input, and we need to ensure that the trigger pin is always low. Then after that, let's go to the loop where the functioning will actually start. Okay, because here we have just said that this pin will be do this. Now in the loop function we actually do what the sensor work will be. Okay, so now digital write trigger pin. First we need to start the pulse, that will be going, pulse will go, then after some microseconds delay we just need to do it low. So now there is a pulsing function in Arduino itself that it will calculate the time, measure echo high time, how much time it was high. Okay, so it will calculate that time and using that time it will convert it into distance. Then there we go, we have got the distance that we need to get. Okay, so now I'll be uploading this code. For uploading the code you just need to click on this arrow, it will compile the code and upload it, so you don't have to compile it already. Okay, let's get started. Okay, the code just got uploaded. Now we need to see like what's the distance, how can we know the distance. To get the distance we just need to click on this right top serial monitor. This serial monitor just got connected. See, it should be on no line ending and you need to set the baud rate that you set here. Okay, so this is 9600 baud rate. See, now you are getting the distance. Right now this distance will vary. If let's say I will use my hand, see, it's saying 7 centimeter, 5 centimeter. If I take my hand away, it will increase. Okay, and it will keep on increasing. But of course you are not able to see it. I forgot, my bad. Wait, let me show you. Here is the ultrasonic sensor. So see, if I bring my hand close to it, see, it's calculating the distance. It's saying 4 centimeter, 4 centimeter, 3 centimeter. Now if I increase it slowly, it's increasing. So with this we can measure the distance, okay, of any object. But you have to make sure that it's plane, because if it's curved the waves will get bounced back in some weird directions. Okay, this is our first sensor. Let's get to our next sensor. Serial monitor closed, this thing. So the next sensor according to our guide is servo. So now we'll be using this MG90 servo. Let's disconnect our ultrasonic sensor. As these are already female, we will need to have male to male connectors for it to get connected to our Arduino. Orange to orange, brown to brown, and red to red. It will just make it easier for us to differentiate. So here our servo is connected, but we can't see the movement just like this. We need to add the attachment that we got with our servo. It is this. So see, this red pin is our power pin, that is our positive. So we need to connect this to our 5 volt power supply. Then this goes to ground, that is our negative that we normally know, and now this is signal pin. Signal pin goes to pin number 13. You can change it if you just change the defined value in your code. Okay, so now let's get to our code. The servo has been connected. Let me just keep this on the sides. Ultrasonic sensor has been used. Okay, so here we copy our code, go to Arduino IDE, select all, paste. This is a normal code for controlling the servo. See, here we are defining the pin number, my servo.attach pin number 13. We need to set the initial position of our servo, that will be 0, and we just need to declare servo my servo. Okay, now let's go to loop where the code will actually be. See, this is a for loop, like it will run for as long as that condition is true. So initially position is 0, and this condition is sweep from 0 to 180, 0 till it's 180, and increase the position by 1 degree each time. Okay, and there is a delay, and this is just the revision, not revision, it's just a reversion of this 0 to 180 to 180 to 0. That's all, and this delay has been added so that it can function properly, because they can't function at very high speed. Okay, so now let's upload this code. Code has been uploaded. Now let's observe. As you can see, this is going 0 to 180 and 180 to 0. This is a normal sweep code that we are using. Okay, so now, but this is just, randomly it's just going 180, 180, 80. What if we want to control the actual direction of this servo? So to do that, we will first learn about one more sensor that I'll be showing you. Okay, so the new sensor that we'll be learning about for controlling these servos will be a potentiometer. Okay, so let's show you my hand cam. Okay, so see here, right here we have got our potentiometer. Okay, what it does is by changing resistance, it changes the voltage. Okay, so with change in that, we can control the position of this, because they vary from 0 to 1023. Okay, when I say they vary from 0 to 103, I mean that the value of this potentiometer ranges from 0 to 103, that we need to map according to our servo's angle. Okay, so let's first see how to connect this thing to our Arduino. For that, we need to have a breadboard. Okay, I'll show you what a breadboard looks like. So these are the two pieces of breadboard that I have attached together. You can just separate them easily just by doing this. This is a breadboard. Okay, so what you need to do is just connect this potentiometer like this on your breadboard. After you have connected this, you need to get your male to male jumpers, 3 of them. Then after you've gotten your male to male jumpers, you need to see how to actually connect them. So ground goes to this pin, that is rightmost pin. The middle one is for your output from the potentiometer. And the leftmost is for VCC. Now as we have gotten them connected, we need a 5-volt power, but there's only one 5-volt pin and there's one more, another here. So the gray one goes in 5 volts, The black one goes in ground. And our power pin goes in pin number 11, where we'll be doing the digital read of the analog data. Analog read, my bad. We have gotten our setup connected. Now let's go to our example codes. See here, right here I have told the connection that we need to make. Okay, I made a mistake right there. You need to connect the output of this pin to A0 analog pin, not 11, and you need to connect the servo to pin number 11. Okay, now it's correct. Copy this code, paste it in Arduino IDE. Now for time for explanation, we have declared it as A0, that is our analog pin 0, pin number 11 for servo pin, baud rate we have set as 11555200. We are just printing this value, servo. So now what we are doing here is we are reading the analog data that we are getting from the potentiometer. Okay, but that potentiometer data ranges from 0 to 103. We need to map it to 0 to 180, that is in degrees. So this is how we map our data. Okay, then this is just normal code that we are comparing and controlling our servo. Okay, now let's upload this code. Okay, done uploading. Now let's see if it works. See, as I'm slowly rotating this knob, the direction, angle of the servo is changing. So in this way we can control a servo motor. Okay, now here we are done with this. Now let's get to our next sensor, that is also it's an LCD I2C scan and address test. So what we'll be doing is we'll be using our LCD display and printing. Oh, okay, I forgot to show you the hand cam. Okay, see, this is the LCD display. Okay, here you have this many pins. Okay, to convert this many pins to just 4 pins, we have used this chip that converts this thing to an I2C protocol. So what I2C protocol does is it just converts all this many pins into just 4 pins, that is ground, VCC, SDA, SCL. To study more in detail about this SDA and SCL pin, you will have to search that on your own. For now, I will just be showing you how to connect it and how to use basic codes. So this is our ground pin. It's better to just normally use brown and red, like brown with ground and red with VCC, because it just helps us sort out the VCC and that without even having to look at the pin it's connected. Because now I know red one is our 5 volts, brown is ground. Now I just need to connect SCL and SDA. So the pins that have been provided on Arduino for SCL and SDA are A4, that is analog pin 4 for SDA, and analog pin 5 for SCL. This is the backlight that just turns on when you give it power. And also you need to adjust the potentiometer behind this to control the contrast and other things to make this display visible. Okay. Now how to scan the address. Let's get back to our Arduino IDE. This is the example code. Let's scan Arduino IDE, Control A, Control V, upload. Uploading done. Serial monitor. See, serial monitoring is running, but the baud rate is at 115200. Let's set it. Now it's printing its value properly, that is I2C device found at address 0x27. Done. So now we are sure that the address is 0x27. Like it will be different it can be different sometimes, so you just need to always check it. Okay, so now as we have checked it, we can just proceed forward with our actual code. But to make that code, we need to first do one thing, that is download this liquid crystal I2C library. Okay, so how to download a library? We just need to go in this thing, this library manager. Type should be all, topic should be all, and just search liquid crystal. But see, you need to copy exact words that I have said here. Okay, liquid crystal I2C, because they can differ. So you just copy and paste that thing like it is, and see the one that you are seeing at the top that I have already installed by Martin someone. You just need to have this installed. Okay, now after you are having this installed, you just need to go copy this code. It's stuck. Okay. You need to just copy this code, go to Arduino IDE, select all, paste, and upload this code. Now as it's done uploading, I will show you the actual what's happening on display. As you can see, it is printing. This is a LCD test, hello world. Okay, you can remove this plastic if you want to. This is our LCD test, hello world. Using this, we can even display the distance data that we just got from our ultrasonic sensor. Okay, so now as we are done with this one, now let's go to our next sensor. That is PIR motion sensor. Okay, so I'll show you what the motion sensor looks like first. This is the motion sensor, it just detects the motion. Okay, so how it works is that it's not like transmitting, receiving, it's just receiving. It just detects the IR radiation that's coming from warm bodies, and using that it just tells it that some motion has been detected. Like all human beings have some IR above absolute zero, that is around 8 to 12 micro something. Okay, so now I'll be doing the connections that you need to make. You will need some male to female. Connect them. Remove this LCD display. Okay, I forgot to turn it on again. Hand cam. Okay, so this is our PIR sensor. I will be putting it signal pin on pin number 13. Okay, so the rightmost one is our output pin. No, not output pin, it's a VCC that you need to connect to 5 volts. Then leftmost is the ground, and the middle is output. That output will be connecting according to our code. In our code, output has been set as pin number 3. I won't be explaining this one in detail. You just need to see this. This is our code. I've copied this code. I'm going to Arduino ID, Control A, Control V, send. Now this is being uploading. Okay, uploaded. Code has been uploaded. Okay. Now what will happen is, whenever it detects some kind of motion, the LED that will connect to this pin number 13 will light up. That's all. Okay. Calibrating sensor, this thing is done by on its own. Sensor active, another things. See, after it's done calibrating, it's saying sensor active, motion detected at 30 seconds. So this is how it works. You just need to connect a LED with a resistors around 330 ohms on pin number 13, on digital pin number 13, and it will light up whenever it detects some kind of motion. Okay, so now this sensor is done. Let's get to our next sensor. Okay, next sensor. Our next sensor is IR sensor. Let's get it connected. Okay, this is our IR sensor. How it works is just light gets reflected, it comes back, there's a transmitter, receiver, black light absorbs, so it will give 0, but other like this one will give 1. Okay, so let's get it connected. As now I don't need to see, I know brown is ground, 5 volts is red, and orange is signal pin, and signal pin is pin number 7, digital pin number 7. Okay, now I need to copy the code, copy it, go to Arduino ID, Control A, Control V. This is the normal pin mode 7. Pin 7 is input, like we are taking input from the IR sensor. Communication speed. Pin number 13 is our output. That means it's just an LED. Okay, that you will have to connect. Upload the code. Uploading. Done uploading. Okay, now why I am not connecting LED is because we can just see it on serial monitor now what's actually happening. So see, I'm not showing cam right now, but if I bring a black color thing in front of this IR sensor, see, now it has turned to 0 because black color is absorbing the light. But now if I just bring my wait a minute. So what happens is, if you adjust the potentiometer that's on this, wait, I'll show you. If you adjust the potentiometer that's on this IR sensor properly, what it will do, it will also help you detect objects. Okay, so see, if I bring an object near it, see, and you can see an LED lighting up. So you can also use this as an object detector. And if you set it properly, this potentiometer, what it will do is it will give low on black colored surface, because light means that the emitted thing won't get reflected. So if it's not getting reflected, it won't come to receiver, so it will read it as low. Otherwise, in normal condition, it will be 1 only, that is high. So this was our one sensor. Now let's get to our next sensor again. Now there is not just a next sensor. What we'll be doing is I'll be showing you how to combine these sensors. Okay, so we will be combining servo, ultrasonic, and an LCD. Okay, so here now we have our LCD, servo, and ultrasonic sensor. First, I'll be connecting them. For ultrasonic sensor, trigger goes to 10 and echo goes to 9. So this is our echo pin and this is our trigger pin, and as we already know, red is for 5 volts and brown is for ground. Ultrasonic sensor connected. Now we need to connect this servo. Now as you can see, now we have only 5 volts and 5 volts. Now we don't have any more pins. So what we can do is we can use a breadboard. Okay, and just take this 5 volts out from here onto this rail. What happens is here the 5 means row till here, middle point, that is 1 2 3 4 5, these are connected to a resistor. So now we have like 25 pins for 5 volt itself, and we can do the same for ground. We will need one more male to male jumper. So here is our ground and we connected it onto this negative rail. Okay, now I know that LCD on LCD display A4 is for SDA, that is our orange pin. So it will go on A4 and SCL yellow will go on A5 and red goes in positive and brown goes in negative. As you can see, backlight has been started. It means it's getting its power. Now last, that is our servo. It needs to be connected. Red goes in positive rail, brown goes in negative rail, and this orange one goes in pin number 13. 9, 10, 11, 12, 13. Now everything is connected. Now I will be showing you the sensor fusion code. By the sensor fusion means something else. Here we are just using all this sensor together, that's all. Copy this code, Arduino IDE, Control A, Control V. But as you can see, this is such a big code. And normally if you don't know much about coding, you can't write this. But there's a way. Like I told you now, that I'll be teaching you how to use ChatGPT and AI and stuff to code. So now what you can do is, on your browser, just search ChatGPT. Here just sign up or stay logged out. Now here you just need to use your example codes that I have given here. So see what we are using an ultrasonic sensor and I2C display. So just copy this code, paste it here, then go to your next code, that is servo sweep. Paste that as well. Then what more we are using? We are using ultrasonic sensor as well. Copy this one. Go to ChatGPT and paste this code as well. Now tell it what you want to do. I want these three codes to be combined. I want ultrasonic distance to be displayed on a LCD display. Okay, and let's see what we want our servo to do. So what we want our servo to do is, whenever it detects distance below 15 centimeter, like ultrasonic sensor, whenever ultrasonic distance is below 15 centimeter, I want it to sweep once, otherwise remain still. Help me combine all these example codes into one. Like, you can write anything. The more relevant you write, the more better you will get output from this AI. This is not a relevant one. Okay, you can just copy this and open ChatGPT again. And just ask it, please refine this prompt for me. See, in this way it has been refined, but this is just a better prompt. You can also give this thing as well, it will still work, but it's normally better to just give this. But I will be testing it this only. Okay, to see. Now our ChatGPT is on its work. It's giving us the code, final combined code. Okay, let's copy this code. Go in our Arduino IDE, Control A, Control V. Let's check if the pin numbers are correct. Pin number 13 for servo, that's correct. 10 and 9 for trigger and echo, that is also correct. Now we can just upload this. Uploading. Now it's done uploading. Let's see our cam. Now see, as you can see, IR distance is being updated. Okay, on this display you can see the distance. Now what if I go below 15 centimeter? See what it does. It does sweep. It did the sweep once. Now I changed. Now let's see what happens if there is no distance again. It stopped sweeping. So now if I go again, it will start sweeping. So in this way you can just ask AI to do whatever you want it to do. This was just an example of what things you can do. You can do more. I'll show you the code that I had made. Here is the code. Wait, I'll show you. See, this code I had made, I wanted it to spin only 90 degree. That is once. So let's see if that is working as well. Done compiling. It will be uploaded now. Now see, it goes 90 degree and stays 90 degree till I haven't moved it out, and now distance is more. Now I have added a 5 second or 3 second delay, I think, where it will just wait for it to the distance to be changed and then it will come back. See, once more. Now see, there will be a delay and then it will start again. Done. So in this way you can do anything you want if you just know the basics of the sensors. Now let's see if there are any more sensors left for us to cover. Handcam, buzzer. Yeah, there's a buzzer also. So I will show you. This is the buzzer. Okay, this is our buzzer. Middle is our input output pin. There are different kinds of buzzer. You may find some buzzer that are just 2 pins. You will need to search on some web to see how to use this. This is the one that I had right now, so I'll just show you how to use this. Okay, so again same thing, you know which color goes where. Just connect them properly. And this input output pin, see, just because I gave it voltage, it's already making sound. Okay, and this pin goes in pin number 9. We need to remove these things, I think. This is pin number 9. Let me get rid of this sensor that we are not using anymore. Okay, now it seems fine. This display also needs to be removed. Now you will be hearing quite a sound right now. Now let's go to our Arduino IDE, Control A, Control V, upload the code. Now do you see the sound it's making? But you can change it. The sound can be changed. Okay, you just need to go here. It's playing at 50 Hz. You can play it at 1000 Hz. You just need to upload the code again. Done. Oh, now it's more painful to hear. I will just make it let's say 100. Upload it again. Okay, this is variable. Okay, so in this way you can just change the sound. So for example, you can even think of something like there's an ultrasonic sensor. The servo turns 90 degrees, and whenever ultrasonic sensor detects something, this buzzer will play. Otherwise it won't play. You can make any kind of cool projects with this. So now as we have covered the basic sensor, we can make something out of this. So let's get to it. I need to just take this out first because it's irritating. Okay, we have covered our basic sensors. There's some more sensor. This is also a potentiometer, but it's just a cool one. It's in the straight direction. If you increase, it will increase. Here it will decrease. You can make cool projects with this one also. This is a breadboard power supply. You need to have a DC jack for this, like adapter. In this way you can get 5 volts and 3 volt supply from here, because like sometimes Arduino is not enough to supply, like let's say if you are using 10 servos, Arduino won't be enough to supply all of them. So you need to use something like this. It just fits right into this, and then rails are just directly connected. You just need to put a jack here. Okay, now this thing's done. Is there anything else? There's one more thing. There's an OLED display that I'll be telling you how to use. after you learn something about ESP32, you can also use this with Arduino also, but I'm going to teach that with ESP32 itself. Now let's get to our example project. Okay, so I have brought out the example project for you guys to see. First, let me clear this mess a bit. Okay, it will be messy anyway. Okay, so see, right now you can't understand anything because how messy it is. This wiring you can't see. I'll be explaining this thing to you through the code itself. Okay, so what this thing does is here. Wait. See, what this project idea, home gate surveillance system. So I have, if you remember, I had attached 3 ultrasonic sensors right there. Okay, so what those does is whenever something is under 15 centimeters, the gates open. Okay, so it's like a opening mechanism whenever it detects something. And let's say I added some LEDs, because if there is, let's say I want to know if there is more than one person. So what will happen if both of the ultrasonic sensors are also detecting something, the LEDs will light up. So it will tell us if there is more means more people or something like that. So that is all the wiring that has been done. Let's get to the code so you will understand somewhat what's happening there. Okay, and this thing also you can use AI to make. Okay, so it's just your ideas. You just need to tell your ideas to that and use the example codes and you'll get what you want. But you just need to tell it properly. That's all. So see, so now here is a constant in trigger 1. As you know, this is just declaration of the 3 ultrasonic sensor. Then this is including our libraries. This is servo pin declaration, as there's 2 gates, there's 2 servos. Then there's just like delays that we'll be using, and then this is the whole code. But of course you don't need to actually write the whole code. If you know, it's good to write by your own. If you don't know, it's still okay, because you can use AI. So now one more thing that I forgot to tell, on LCD display that I have added, it just says welcome and CI. That's all. So now I'll be showing you how this example code is actually working. Okay, wait. So I will just, I have already uploaded this course, so I'll just power it on. And cam. So see, I will just connect this. Remove these wires. Will be problematic if they get in between. Okay, my camera battery had run out. Let's start again. So see, as you can see, with this one and this one, the LEDs are lighting up. We are getting to know the crowd density in people, like how many people are there. Let's say if there's 2 people, they are standing here, we'll know, okay, 4 LEDs are lighting, so 2 people are standing there. So now how will the gate open? So the middle ultrasonic sensor, now I have set for it to open the gates. So see, the moment I do this, the gates will open. Okay, now as the gates have opened, now after a 3-second delay, it will close back again. So done. So in this way, like I have made an home surveillance system, but like you won't always be looking at the LEDs and stuff when you are inside the house. So to tackle that problem, I am going to introduce something to you that will be an ESP32 board. So what that ESP32 board will help you do is that you will be able to get the data from here wirelessly on your phone, like a person detected, a dog detected, someone is in front of your house, do you want to open the door or something like that. So right now this is a simple Arduino project that is like a surveillance system at a really low level. So now if you want to make it at some high level, like you will get data and phone, etc, etc. It will also tell you there's like if there is dog, cat, human, some kind of thing, so that you will be notified whether to open the door or not, because this thing right now is opening door for anyone. You don't want the door to be open for anyone. So now I'll be teaching you about the ESP32 and other things. Let's push this project aside for now. So this was our home surveillance system. The pins I have already explained. This is the breadboard and this is our Arduino. That's all. So I have brought out the ESP32 that we'll be using. So this is the ESP32 board that we'll be using. I'll be sharing the pin out of this in the document that will be shared. So for this ESP32, as you can see, there's only one pin and there's no breakout board. What you can do is just attach these two breadboards like I showed you in the start, like this. There's attached. Now you just need to take your ESP32, place it at the ends like this, and you are almost done. Okay, now after you have settled down like this, you need a micro USB cable to program the ESP32. Okay, now that we have got our ESP32 hooked up, we need to do some kind of setup in our Arduino IDE. So first of all, go to Arduino IDE, open file, preferences, and here you can see additional board manager. Whenever, if there's a link already pasted here, first put a comma at the end and then press this exact line that I have copied right from the document that I'll be sharing with you. It's this line. Just copy this and paste it directly there and don't forget to add a comma. Okay, then after that you have added it. Now you need to go to your tools. So now go to tools, board manager. Here you have to search ESP32. Now you will see ESP32 by Arduino and ESP32 by Espressive Systems. You need to click on that and install it. As I have already installed it, it's showing update for me. You need to install it. After you installed it, you need to go to tools again, board, then you will see an ESP32 option. You need to go under ESP32 option, then you need to select ESP32 dev module. Normal, only ESP32 dev module. Click that. Of course, the way I showed you to check the port from driver manager, you also need to check that if it's the correct port you have added. As here you can see, it's already showing COM20, so I am not going to check that. So now this is the basic setup that you need to do to be able to program an ESP32. So now let's have our example code with ultrasonic sensor to get the distance data in our ciliary monitor. And there's a step to be able to upload the code to an ESP32 that I will be showing you now. On ESP32, red goes, as I have told you, red is for positive, so red goes on 5 volt, brown goes on ground, and then there is an echo and trigger pin. Oh, I forgot to show you the hand cam. Wait. Red one goes on power 5 volt, brown goes on ground. Then your echo pin goes according to the code to pin number 18. You will see it as G18. G18. Now you need to add the trigger pin on G5. You will find the G5 just beside G18. Okay, now after you have added everything, now you need to upload the code. Here you have to pay attention. When uploading code, after you have compiled, you need to press and hold the boot button just till the process of uploading starts. Okay, just see, I will show you. See, it's now compiling sketch right now. It takes some time. Till that, just see the ESP32 where I am going to hold boot button. Okay, it's getting compiled still. Let's get back to our Arduino IDE. It's still compiling, soon it will be compiled. It's getting compiled. Now you need to press and hold the boot button. See, I'm holding the boot button right now. And what's happening here is, see, it has started to upload now. See, after this arrow thing starts, you can just leave the boot button. It has uploaded. Okay, now you need to see the serial data of this ESP32. So just how you normally open the serial monitor, you have to click on the right top corner, serial monitor. Set the proper baud rate. I have already set it. No line ending 115200. Here you are getting the distance, and it is correct. Now, as we have added this ultrasonic sensor, of course we should use a display to display its value. So we will be using this OLED display that we had seen at the start, and we are going to use it to display the distance that the ultrasonic sensor is measuring. So let's first get to our example codes here. But first here you need to download a library called U8G2 by Oliver Krauss. Okay, you just need to copy or just type this U8G2 directly in your Arduino IDE. It's U8G2. No, sorry, this is board manager. You need to go in this section exactly, library manager, and then UG82. It's not showing. Let me check. What was it exactly? U8G2. Okay, that's why I made a mistake. U8G2. Now see, U8G2 by Oliver. You just need to install this. As I have already installed it, it's showing remove. Okay. Now as this is done, we need to get back to our sketch, and we need to copy our example code. This is our example code. Just copy this. Take it, Control A, Control V, code pasted. Now you need to make the connections first. Red goes in power pin, brown goes in ground, and other pins according to C. Now here also it's working on I2C protocol. So you have to know which pins are for A4 and A5. So according to that we'll be putting this. Oops, I forgot the A4, what the A4 and A5 for this ESP32 are. I forgot the SCL and SDA. Let's try searching on Google. Let's search ESP32 dev module pinout. Here in images, if we go and find the exact one that we have, this is how many pins? This is the one that we have. So let's find where the SCL and SDA. Okay, I can see SCL on G22 and SDA on G21. So we should remember SDA is G21. So now let's go back to our hand cam. From here, SDA goes to G21 and SDA is orange. So let's put this thing at G21. Okay, this is G21. We need to put this at G22, that is SCL. Yellow was our SCL. Let's put it. Now let's upload the code. By the way, this code is just for testing the OLED display. This won't actually display the ultrasonic sensor distance just now. First we'll test how this display works, or if it even works. And as the same process as always, after it's done compiling and it's in connecting, we need to press and hold the boot button till it starts. It's compiling, it's taking some time right now. Okay, I skipped some time for you because it was taking too much to compile. Now as it's compiled, I'll be pressing the boot button. I have pressed and hold the boot button. Now it will start uploading. Okay, it has started. Let's wait for it to start properly. It started, now I can leave it. Okay, now let's come back to hand cam and let's see. You can see that it is printing now, hello ESP32. You might not be able to see it properly, but of course you can see that there is something being displayed. Okay, So it's showing hello ESP32 right now. Because of its font size, camera won't be able to see it properly. So now, what did I say we'll do it at first? We'll show the distance on this OLED display. So let's get back to our code. Here, display ultrasonic sensor on OLED display. Even if you don't have this code, as you have my basic codes, you can just copy this code as well, and just go here, give it to ChatGPT, and do the same thing that I told you just now. Here you can give code normally, or ask ChatGPT itself to refine your code for you, and then send it to ChatGPT again. Okay, so now let's go to our Arduino. As you already have our code, we don't need to do that. We are here. Let's check if our pins are correct. Pins, we have connected G5, G18. Okay, they are the same. These are SCL and SDA, so we don't need to check. We already checked on G20 and G22. Now we just need to update this code. Now we are uploading. It's compiling again. This time it seems to be taking the same amount of time. Okay, no, it's doing it fast. Now we just need to press and hold the boot button at correct time. I pressed and hold the boot button. Okay, it has started here. Okay, now I can lift off. It has uploaded. See, in serial monitor it's doing, but let's see if it's showing actually in our display. And see, this time font is bigger, so you should be able to see it on zooming properly. See, 57, 58, 57, it's showing the distance properly now. Because this time the font is big, so you should be able to see it at least somewhat. It's in centimeters, okay? See, now it's in 3 centimeter, 4 centimeter, 2 centimeter, 1 centimeter. After 2 centimeter, on the smaller side, it won't be that accurate anymore, because 2 centimeter is its almost limit. And this is right now it's 160 centimeter. Okay. And when it's out of range, it will print timeout. Okay, so this was our OLED display and ESP32 usage together on an ESP32. And you can also print these things wirelessly. Okay, so that also I'll be teaching. Okay, I've already done the setup for our next thing that we are going to do. The next thing that we are going to do is wirelessly control this LED that I have connected through G2 with a resistor of 220 ohms on the positive terminal of LED, and negative terminal is connected to the ground. So now let's see. Let's go to our example codes. Copy this code. Okay, then go to Arduino IDE. Okay, I need to stop this serial monitor. Go here, print this. Okay, I need to change the Wi-Fi credentials. So see, whenever you connect, you need to connect, tell the name of your Wi-Fi, the SSID, and password. Okay. Here you need to enter your SSID, and here you need to password. SSID just means the name of your Wi-Fi again, and everything is there, connected to Wi-Fi, local server. Other things I'll be telling you. See, these things, if you know how to code on Arduino IDE, then you will be able to understand this and do this. If you don't know, then you may use the method of using this example code and giving it to the AI to do what you want it to do. Okay, but that's not always a preferred option. It's better to learn first, but if you don't know, then you can try doing this. So now I'll be closing this window for some time, because I'll be entering the actual credentials of the Wi-Fi. Till that time, you can just see the hand cam. I'll be entering the credentials. Okay, I entered enter the credentials, back to the code. Now we will upload. Do not forget, during upload you need to press and hold the boot button. It's taking time to compile again. Okay, it has started compiling now. It's halfway there. Get ready to press your boot button. Okay, it's uploading. Now what we need to check, if this thing actually got connected to IIIT, means not IIIT, if this thing actually got connected to Wi-Fi or not. Okay, so let's see. Serial monitor. Okay, I'll press reset button to start the serial monitor. It is connecting to Wi-Fi. Okay, it got connected to Wi-Fi. Good thing. Now what we can do, we just need to copy this IP address. Okay, copy this. Go in your browser, just enter it and press enter. See, now you can see there is a turn on and turn off option, but now I will be showing you through here if it's actually turning on or turning off. See, are you able to see? Maybe not. I'll switch to hand cam. See, it's turned on right now. Now I'll turn it off wirelessly. You can hear the clicks of my mouse. Turn on and turn off. In this way you can wirelessly control things also. Okay, where is this? So in this way you can make your project wireless. Turn on, turn off. Okay, but you must be thinking how you will do this. If you know how to code, then you can just do it. If you don't know, you can just copy this code, go to ChatGPT. Here you can just say, this is my example code for LED control. Instead, I want to use it to control and servo. Anyway, a servo. Okay, let's get, I have a servo. Where it wants us to connect, it wants us to connect it to GPIO 13. So I'll connect this thing to GPIO 13. I see 13 right here, and one goes to power pin, that is 5 volts, and another one goes to the ground. After I've plugged in everything, I need to go to Arduino IDE and paste this code that I got from ChatGPT. So let's just copy this code, then go to Arduino IDE, Control A, Control V. Now I need to change the Wi-Fi credentials, so I will be doing this again. Back to the screen, compile. It's compiling the sketch. Oh, there was an error. Hashtag include servo.h. Okay, so now what I'll do, I'll just print this error to ChatGPT. Control C. I got this error. What should I do now? Okay, so now what it tells me, download this library ESP32 Mayday 5 this. Okay, so first we'll try doing it the normal way. We'll go to library manager, we'll search ESP32 servo. ESP32 servo. So let's see if I can find the one recommended by the ChatGPT. Sebastian Matos. Let's check what was the one that was given by him. The one that he gave was Made Faistus. I don't think this was there. Was it? No, it wasn't there. So now what we can do is go here, the link that they gave, download zip. Okay, now it got downloaded. I just need to navigate to the folder it was downloaded. File manager, I need to go in file manager. In file manager I need to go in downloads. Wait, in file manager I need to go to downloads. In the downloads, this is that zip file. I need to right click on it, extract all. But extract all to where? I need to browse. I need to go and print this in, go in documents, go in Arduino, go in libraries, and just select this folder. I need to extract it here because that's where the libraries are stored. Okay, now I have extracted. Now we have our library. So close this file manager, go to Arduino IDE. Now let's try doing it again. It's taking time to compile. Okay, it's almost compiled now. It's uploading time. Okay, done with the uploading. Now I need to check the serial monitor again. I'll press this reset button. Okay, it's connecting to Wi-Fi. It connected to the Wi-Fi. Control C, copy this. Go to my browser. Go here. Paste. Enter. Okay. Now see, it's saying rotate 0 degree. Now this is rotate 180. So now we gotta check if this thing is working or not. I will reload this. Okay, it's reloaded. Rotate 0. See, did you see that? It rotated to 0. Now rotate to 180. See, it went to 180. Rotate A. Rotate 180. See how smoothly and fast it's working? Okay. Now let's try. Okay, I'll show it from top view also. See, I'm controlling it wirelessly. This way even you can do it. Okay, let's stop this now. Now as we can control things wirelessly, to make it truly wireless, we also shouldn't be present there, right? We shouldn't be looking at it. We also need our eyes for that. So for that, I will be bringing out ESP32 cam that will learn how to use. This is the ESP32 cam that we'll be using, and this is the FTTI programmer for that. As there's no port for uploading anything here, we'll have to use this FTDI programmer. So now what is this FTDI program? Here what happens is, see, you have to buy this cable, okay, for this, with this FTDI programmer. What you can do with the help of this is the things that you are not able to program, let's say, because the things that don't have port. So what you get here is ground, power, and TX RX pins, like transmitter and receiver pins. So you can use this to communicate with different kinds of protocol with different kinds of board. So as we can see, this ESP32 doesn't have it, so we can use this FTDI programmer that I have got right here to upload the codes on this thing. Okay, so now I'll be giving you an in-depth guide on how to use this ESP32 camera. Okay, so let's get to it. First, let's just mount it on our breadboard. But while mounting, just remember, you need to be able to reset, and the reset button is below, so you may get multiple problems because of this. So let's just do one thing, we'll just connect this via jumpers itself. Instead of having this female to male connectors, we'll use female to female connectors now. How many do I need? I need only 4 for power, ground, TX and RX. Let's take out 4. Let's try to match the color combination again if it's possible. VCC goes in red color, RX goes to orange, TX goes to yellow, and this green goes to ground. Okay, now I need to plug this in the camera also. In camera, you need to first make sure, see here there's 5 volt, so you need to short this 5 volt and this middle pin with this. Okay, if you are going to connect this with 3.3 volts, then you need to take this thing out and put this thing on the left side. Okay, but now we are using 5 volts, so I'll be putting it this here itself. Now this red cable goes VCC 5 volts, so we need to find the 5 volt pin. Where is the 5 volt pin on this ESP32 cam? It's right here. One thing that I would like to tell you, see, normally all the grounds in a board are shorted. Okay, by shorted I mean they are all connected to each other, but there is a problem in this ESP32 cam. All are sorted with each other, grounds, except this ground that is on this edge near the LED. So make sure you don't use that ground because it won't work then. Okay, so now we are doing this. Now we need to connect the TX of FTDI programmer. What was our TX? TX was yellow, right? Yellow. It was yellow. So we need to connect this TX to the RX, that is UOR of camera, and we need to connect RX of FTDI to TX, that is UOT of your ESP32 cam. Okay, I got the wire stuck. Yellow was our TX, so it goes in RX, right? Our RX goes in TX, our ground goes in ground, and then one most important thing right now, we need one more female to female jumper. I'll get you through a upload process that you need to follow. For doing this, you need to first short ground and IO0. you need to short them together with female to female connectors. Okay, now we are done with our setup. Now we can just remove this ESP32 right from here. Just put it somewhere else on this corner. Take out this cable also, we don't need it anymore. Insert this cable. Okay, now everything is connected. Now, number one thing we need to do, you need to see my screen first. Let's go to Arduino IDE. Here, Control A, backspace, file, example codes, ESP32, camera web server. This is the only thing you need to do right now. Then you need to click on this and click as AI Thinker ESP32 cam. If you don't get it directly, of course you won't. So what you'll have to do, you'll just, oh shit, okay, my bad, wait. So here what you have to do is 3321. Okay, here what you have to do is go here in board config.h, click on this, press Ctrl/, okay, and press Ctrl/ while selecting this define camera model AI Thinker. Okay, after you are done with this, go to camera web server, enter your Wi-Fi credentials, okay, and then upload this code. I'll tell you the upload process. First I'll upload Wi-Fi credentials. Okay, I have added my credentials. Shift. I have added my credentials successfully. Now back to the code. Now I need to first thing you need to do. You need to press this reset button while both of them are shorted to put this in a downloading mode. Is the only mode in which it will allow us to upload the code. So first we need to press and hold this button, that is reset button. Okay, so how will we know if it started? Okay, just go in serial monitor, see it's showing waiting for download. I'll show you on cam also exactly where I pressed. Wait, here just below here there is a boot button, not boot button, there is no boot button here, there is only reset button. So you need to press and hold the reset button while ground and IO0 are connected to each other. Let's go now back to our Arduino IDE, upload this code. It's compiling the code. It's compiled, now it's uploading. Just know this thing uploading is only happening because we shorted them and pressed the reset button, otherwise it wouldn't happen. So make sure to do that first. And even after uploading, if you want to run the code, you'll have to do one more thing that I'll tell you just soon, right about now. Let's first check the serial monitor. Okay, in serial monitor nothing is showing. So now what you need to do is, see, you need to remove the shorting that you did. Okay, now press the reset button again. After pressing reset button, see what's happening. It's trying to connect to the Wi-Fi. Okay, it connected to the Wi-Fi. Now what we can do, just copy this link, go to our browser, paste this, enter. Here we go. Now we just need to press on start stream and we have our own camera, wireless. We can even increase the resolution to maximum, but it's just that FPS will be really low then. As you can see, we can do, see, now it's working fine. Now you have a wireless live feed that you can use with ESP32. So what my goal was to tell you this was, I just use Arduino IDE. Okay, I only used Arduino IDE and Arduino with that home surveillance system. What you can do is just a minute. What you can do is use ESP32 in that home surveillance system. Like at the camera, you will have a live feed on your phone. But make sure both of them should be connected to the same Wi-Fi. That's a given. Okay, both of them should be connected to the same Wi-Fi for this to occur. Okay, then you can get notified if someone is there. You can allow to open the door or not. It won't be automatically open. It will be like you will get a notification whether you want to open it or not. And there's one more thing, last but not least, I'll be giving you like a homework, one link at the end of this documentation. It will be on how to use this model, okay, camera module with what do I say that with a trained model, so that this will be able to differentiate between a human, a cow, a cat or a dog, so that it will only open the gate if it detects a human. So for that I will be giving you a homework by giving a link so that you can try it on your own. Okay, I have given you every basic type kind of code that you might need. You even have your wireless stream now, which you can of course see again if you want to. See, this is your wireless stream. You can change the resolution also. Here it's quite good. Only if I just decrease the resolution, okay, see now how smooth it is. Okay, not smooth anymore. Wiring issue, okay, but still it's good. Here you can get still, you can get the photo and everything. You can even save it locally on your laptop. Otherwise you will have to add a memory card, and in memory card then you can store it, but memory card gets corrupted easily, so it's just better to store it wirelessly on your laptop. And now done, that's it. Now all you have to do is experiment. If you know how to use or not, if you know how to do coding, then it's good. If you don't know, you can still try. I showed you a way, but you just need to correct the errors and everything properly. Like just now we got an error on how to, means there we were not able to run the code that was given to us by ChatGPT, but we gave the error to ChatGPT and gave us the solution. In that way you can try, but after some time you won't get the solution, because you need to know what is actually happening to instruct the ChatGPT properly. But for once or twice you can use it and get something that you were just thinking about but couldn't actually apply. With AI you can apply everything. Thank you. Try doing the homework that I told you, and it will be a really good home surveillance system that you will even able to apply it on your own home gate. Thank you.